Hi, we shall discuss about the issues in designing a distributed operating system. In the previous video, we have studied about the transparency. It is making the multiple devices invisible. That is the transparency. 8 types of transparencies we have seen in the previous video. By the transparency, how the performance can be improved. That we will see. That is to be considered while designing a distributed operating system. If multiple processors will be there, if one processor is overloaded, the other processor should not be idle. So the processing capability should be uniformly distributed, so that we need intelligent resource allocation and process migration facilities in the distributed operating system. And the next design issue is fault handling mechanisms. The failure may be categorized as two types. One is a fail stop and the Byzantine. This fail stop means if a failure is detected, the system will stop its functioning. That is one category. Another one is if the system functions normally but it produces the wrong results. So these things should be handled by some mechanisms for the higher reliability. So we need to enforce the fault tolerance. So fault tolerance means it continues to function and produces the correct results even if a system gets failed. We have to consider two things to improve this fault tolerance and distributed control. This redundancy technique is that is replicating of hardware and software components. That is, if a critical process is to be executed, it can be executed simultaneously on two nodes. Even if one fails, other process can execute that and complete it there, so that the process gets completed at the another node. Because of this redundancy, the same process can be assigned to two different nodes. Even one node get failed, another will complete the process. So by this, the fault can be tolerated. And here, the distributed control, that is, we know that multiple distributed servers are there in the distributed system. So we expect the servers must be independent. So here, if some simultaneous functions are assigned to the servers we have to take more care. Sometimes even in case of a simultaneous process, the reliability can become worse. So more care should be taken while performing this simultaneous functioning in the servers. Fault detection and recovery. To handle this reliability, to improve that reliability of a system, we have to detect the fault and recover. Some techniques can be followed. One is atomic transaction, stateless servers, acknowledgement and timeout based retransmission of messages. Atomic transaction is either all the operations to be performed or none of the operations of the transaction is to be performed. Already we have studied about this. We know we might have studied in the database systems. It should be atomic. That is, in case both the operations are done, so finally we'll get the system in a right state. Otherwise, if one is occurred and another one is failed, means it will lead to the loss of data. To avoid that, we have to take more care on this state. That is, both to be performed or none of the operations is to be performed. And the stateless server, it makes that crash recovery very easy. No client state information is maintained by the server here. Normally, the state of a node or a state of any resource is not maintained not disclosed to the users. Nobody can, the users will not be aware of knowing the status of any resources in the distributed operating systems. And the third one is acknowledgement and timeout based retransmission of messages. A system may lose a message That is, in case of any device failure or the communication link failure, the data may be lost. That interruption may take place between the communication during that communication. So it can be handled by the acknowledgement. If we don't get that acknowledgement, we may assume that the message was lost, and so we'll be retransmitting the messages. We can deal this with duplicating that messages. And the next design, while designing the distributed system, we have to consider another factor, that is flexibility. It is the most important features. Two things, that is, the system should be ease of modification, and it should be easy to enhance the features. Ease of modification, any changes to the system should be done easily with a minimum interruption. And the next one is functionalities. If you want to add a new functionality to the system, it should be done simply, easily. So these are the flexibilities that should be provided for the distributed systems. And scalability is, if a service load may be increased sometimes, so the system should be enough to it should cope up with that growth in the users and also the nodes in that system. And security, regarding the securities, security issues, that is authenticity, and we have to trust the users here. The sender should be trusted by the receiver, and they must have the hope that that integrity is there, no changes have been made during the transmission, and the message is from the right center, that trust should be given. These are some of the security issues that will be given in a distributed system. Thank you.